Let's get this going here. Turn this off so that this will come on. All right, 131 more get-ups. We're almost at day 50. Tomorrow will be day 50. 5/18 of the way done with the year. Okay, just about 1/3 of of the way done. Just kind of nuts that we're a third of the way done. I still haven't seen some of your guys' faces or talked to some of you guys, or it's kind of wild. Today's the 12th. Okay, just as review, talking about building our 4 steps of our unit rate boxes. Okay, unit rates, units that deal with 1, rates that deal with 1, constant of proportionality. Okay, reciprocals, flipped versions of fractions we have, using fractions and their reciprocals to help us find unit rates when fractions are involved. Okay, talking today, I can solve proportional relationships using constant of proportionality. Okay, those of you that were here on Monday and are here now today know I wrote this little tiny COP right here that talks about constant of proportionality. So today we're going to dive into that a little bit more. We're going to be into some equational things, okay? So when we have a unit rate box with like X and Y, okay, we have something like 2, 6, and 5, 15, okay, something like that. We can see what's happening in this from X to Y, thinking about what we did on our Monday Excel and things like that, okay? Notice how all of our units build on the previous units. So those of you that aren't really working through the Excels and aren't really spending a lot of time on the previous unit, I'm sure some of you are probably confused as to what are they talking about? Well, that's the place you put yourself in, okay? Those of you that are keeping up on the units and staying caught up, you should be more in a position to succeed, okay? So we can see from X to Y, we're just multiplying by 3, right? Times 3 times 3. So whatever is happening from X to Y, that is our constant of proportionality. And we're going to look at what that looks like in an expression, in an equation today. Okay, so like Y is going to be equal to whatever X is times 3. So this is your equation for this this unit rate box, this proportional relationship, okay? Anything you plug into this, okay, and this is just X times 3, right? Anything you plug into this, you're going to get an output that's equivalent to the relationship that we have here. Okay, if I take 10 and I plug it in here, okay, Y equals 3 times 10, I get Y equals 30. Okay, so you would get 10 is your input, 30 is your output, right? 10. And it stays proportional, right? You can see I've doubled this, so I've doubled that, right? It's still times 3. So your constant of proportionality is this little piece right here. Okay, and they also call that K, lowercase k. Not sure why. Okay, I'm going to put that in parentheses right up here, lowercase k. So whenever you see somebody in a question asking like, what is K, or find K, they're talking about the constant of proportionality. I'm not sure why they don't just use C. I think C is used more frequently in like A, B, and C as like variable, like as a variable, like as a missing value. So they use K because it's not as constant as common. And so the nice thing is we can look at equations, and we notice that when we have proportional relationships, remember, it's only multiplying, okay? Now, some of you missed the last problem on the Excel because you made this mistake. Okay, so you have something like X and you have Y, and we have like 1, 4, 2, 5, 7, 10. Okay, and some of you said that yes, it is a proportional relationship because I'm adding 3 to each of these. Okay. Now, if you notice and you go back, if you were to go back and review, you won't hear me say anywhere about, excuse me, anything about proportional relationships, about adding from one variable to another. Okay, it's always multiplying, dividing, reducing, fractioning, okay, things like that. Nowhere did we talk about adding things or subtracting things, okay? So you got to pay close attention to that, okay? Look at our unit rate right here. For every 1x, we have 4y. So that should be constant all the way through the relationship, okay? Right, and almost everyone that got 83%, that got 5 out of 6, missed it for this reason. They said, yes, it's proportional because you're adding 3 or because it's 2 more than the last one, okay? But look at it. Remember, we find our unit rates. Our unit rate tells us what's going to happen for every x, okay? For every x, you're going to make 4. So if y is dollars and x is apples, for every apple I sell, I'm going to get $4. So if I look at this other one here, if I sell 2 apples, do I make $5? No, I should make $8, right? I should make 4 for each dollar, 4 plus 4, okay? So keep in mind, no adding or subtracting when it comes to proportional relationships. And that's reflected in our equations of proportional relationships, okay? Notice I have no addition or subtraction in here, okay? Anytime you see a piece where it's like it has addition or it has subtraction, it automatically makes it not proportional. So you can look at equations of proportional relationships and you can see immediately, just by looking at them, are they going to be proportional or not? Okay, it's going to be in the form y equals constant of proportionality x. Okay, and I'm going to write that right here. Y equals kx. This is your form where k is going to be your constant of proportionality. Notice there's no addition, there's no subtraction. Okay, so if I'm asking you to find the equation of a constant, that including the constant of proportionality, find the equation of a chart that's happening here, all you have to do is find your unit rate, and then whatever this number is, it just gets plugged in to whatever your equation of your constant of your proportional relationship is. Okay, so we can look at any. Oh, I still need to clean my board. I did not do that last week. So we can look at any proportional relationship here, okay, where for instance the hours worked plus the money made. Okay, John worked for 8 hours, he made $88. He worked for 10 hours, he made $110. He worked for 3 hours, he made $33. Okay, we need to find our unit rate first of all. So we need to find our unit rate. So essentially our equation, y equals kx, is just another way of showing our unit rate. Okay, so that's the thing I want you to understand, is that unit rate and constant of proportionality are essentially the same thing, okay? So if I looked here and I said, okay, well, what does he make per hour? Okay, I divide by 3 on both of these, divide by 3 to get 3 divided by 3 is 1, 33 divided by 3 is 11. So he's making $11 an hour. So now that I have my unit rate, this is my constant of proportionality. It's whatever number matches up with the 1 in the other piece, okay? So my equation is just y equals 11x, okay? Straight out. This tells us that any number, remember 11x just means 11 times x, right? This tells us that any number that I plug in for x, I'm going to get a y value that's 11 times that value, okay? It's going to be proportional no matter what the x is that gets plugged in. So for instance, when I plug this 10 in here, 11 times 10, I get out for my y 110, okay? So that's the main idea of equations of constants of proportionality, okay? You're going to get some questions on your test and on your, on your Excel and things like that, where it's just going to say given this equation, find the constant of proportionality. Bam, right there, 11, okay? Or it's going to say, given this chart, okay, like this chart here, but minus that end piece, given this chart, what's the constant of proportionality, or what's the equation of this proportional relationship, okay? And you're going to have to find the unit rate, okay? That's why we start with unit rates, because it really opens up where to go for all of the topics in this unit. Okay, unit rate really does a really good job of helping us figure out, like, it's secretly, just constant proportionality in disguise. Okay, so when you're finding these, you're here. Now the nice thing is again, it has to be in this form: y equals kx. That's it. Where x is the input and y is the output. Okay, you're never going to see plus or minus. If you see one where it's like -2, automatically not proportional. Boom, not proportional. No pluses, no minuses. Okay, no addition, no subtraction. Only multiply and divide. Okay, that's the eye check we're talking about, right? With your charts, you're going to have to go through and divide or multiply each one and see if it equals the same thing to see if it's proportional. With equations, it's literally just, is it y equals some number x? Okay, if there's +4, okay, you might get one where it's like y equals x plus 5. Okay, not proportional because of this guy right here. Okay, we don't like it. It makes it not proportional. Okay, all we care about. So y equals x would be proportional, right? Because everything that I plug in is just going to become y. So like in this instance, this will just be whatever you plug in for x, nothing really happens to it, right? It's just 1x. So 8, 10, 3. Oh, what's happening to all these? Well, they're all being multiplied times 1, right? So it would be for every hour you make $1. Okay, something like that, right? So again, that's the big piece that the two big pieces that I want you to take away from this. One is you can eye check any equation for proportionality. Okay, you look at it, does it have plus or minus in it? Not proportional. Okay, now some of them might get a little tricky, like -2 plus 2. Okay, well this would be proportional, right? Because these cancel out, because once you simplify the equation, there's no addition or subtraction. So in the simplified form, but again, you can eye check them. Does it just fit in this y equals kx? You can see y, where k here is the 1. Okay, y equals kx. Okay, that's the big piece. The second piece is that unit rate is essentially just constant proportionality. We're basically relearning a term for something that we've already been going over and covering for a handful of weeks here. Okay, or a handful of units at least. Well, 2 or 3 weeks here we've been for it. Okay. So that's 2/3 of what is proportionality. Okay, we talked about looking at our equations and our charts so far, and we're going to look at graphs probably next week. Okay, graphs are the easiest because they're very eye check. You just look at them. If they meet certain attributes, they are. If they don't, they're not. But that's also true here. Okay, and finding constant proportionality is not necessarily crazy difficult. When you're looking at an equation like this, okay? The hardest piece of this, I think, is taking a unit rate box that's completed or not completed that doesn't have a unit rate. Okay, something like this, where we had, these numbers that were like not unit rates yet. But again, that's not, I don't think, crazy difficult because we've already spent time figuring out how to find unit rates, right? Just putting 1 to something. So now some people will ask, what if I go to dollars? Try to avoid using purple. What if I go to dollars, like $1 right here? Okay, oh, I divide this by 33, divide this by 33, I get 1/11. So how do I know that my equation is y equals 11x and not y equals 1/11 times x? Because I've got a 1 in here. How do I know that this just doesn't plug into right there? That's a great question. It's a great question. Okay. The answer to that is you just kind of gotta common sense it. And a lot of the times your question is gonna, the question that they're asking you is gonna answer that for you. Okay. He's making so-and-so dollars per hour using this unit rate. What is the constant of proportionality? Okay. Dollars per hour, per 1 hour. Okay. So you got to look in your question for that. Also, most of the time that you get some wonky fraction here, you're going to go this way. Okay. 99.9% of the time, Okay, or if you plug it into your Excel and you put, okay, well, 1/11th is my constant proportionality. And it's like, wrong. Odds are you found the wrong one, okay? The wrong one in the wrong place, okay? All right, so that's a basic kind of crash course on equational constant proportionality, okay? All right, this is another one of those units where, like after the unit today, like on if we were in class every day, like tomorrow's warm-up would be like, here's 70 problems. Are they proportional? Yes or no on your warm-up. And you just write yes, no, yes, no, yes, no, yes, no. I wish I could, I wonder if I could just find the one that I usually use for this real quickly. I think I have it saved. Maybe I don't. All right. Where are my warm-ups? I haven't used warm-ups because I haven't seen students in forever. All right, well, it's somewhere. But again, okay. So the unit, the book today. So the book, yeah, let's look at the try it on number 1. Okay, I want to just give you some examples of what this is going to look like in context, okay? All right, so it says Maria made 2 batches of fruit punch. The table at the right shows how many quarts of juice she used for each batch. Write an equation that relates the proportional quantities. Okay, so we can see they want quarts per batch. So batch is going to be 1. Okay, so let's see. We have apple juice, which is our x. We have grape juice, which is our y. They want our ratio. Okay, they want to know what the proportion of apples to grapes is here. So they say, okay, it's going to be grapes over apples. Okay, so they want to know the constant proportionality is. So this is interesting. So they don't really tell you. They give you like what the y is and what the x is in this instance, but they don't necessarily say like, okay, well, what is the ratio of grapes to apples, which would tell you which direction it would go. Okay. So in this instance, you're just kind of showing what they have. You're having y over x. So here it would be just, y, which is 5, 8 over 5, right? 8 over 5, y over x. Same thing here, it'd be 16 over 10, but which would reduce down to 8/5. So the constant of proportionality is 8/5. So knowing that, our equation that represents it is y equals 8/5 x. Okay. When they give you the x and the y, just stack them up like they ask you to here. Okay. It's pretty straightforward. How does the equation change if the amount of grape juice is the independent variable, the x, and the amount of apple juice is the y? Well, it just flips, right? If this was y and this was x, this would just flip, right? It would be 5/8. Now, so this is like y equals 5/8 x. So if you think about like y, I need to erase these now so I can actually see what's what. So like our x is like 5 right here. So if I plug 5 in for this, it'd be like 5 over 1. So 40 over 5, which reduces down to 8 over 1. So our y is 8. So that makes sense. When I plug in 5, I get 8. Okay, that's what they want to be shown here. Okay. So again, some of these can be confusing because they don't necessarily tell you what specifically they want here in relationship to, these answers. Some of them may be, you may just like give this answer and then it is wrong and you just try it flipped. Okay. That can be confusing. I think that's one of the main things that a lot of people miss on these is just they have the reciprocal because it's not clear about which one they want. Okay. Most of the time, it's going to be a little more straightforward. This is not a very good example, but I wanted you to see that it can be confusing. But you got to give, take what they give you. If they say this is the x and this is the y, okay, and they want it like this, y over x, okay, bam, let me give you y over x then. Okay, take what they give you, right? Okay, let's look at the next one here. Oh no, I have another book where it's missing pages. Someone stole them. Okay, one sec. Hold on. I hear a pen. Someone stole the pages from my book. That's what I get for going cheap. I try to use a student copy. Missing pages. Oh well. All right, 107. Let's find this here. Okay, 105. Here it is. All right. So, yeah. Okay, let's look at our next example here. Do we want to do 2 or do we want to do 3? Let's look at 2. So 2 says an inch is 2.54 centimeters, which is true. How many centimeters long is an 18-inch ruler? So we need to write an equation to represent this relationship. Okay, so y, our output, our answer, is equal to k, which is our constant of proportionality, times x. So in this instance, we're going to be multiplying inches times however many inches there are times this 2.54 to get centimeters. So 2.54 is our constant of proportionality, what we're multiplying by. Think about if I built a unit rate box, right? So 2.54, if I built a unit rate box for this, okay, and this is a good strategy to fall back on. If you're not really sure, just try to build a unit rate box. What would it look like? Okay, so if I built a unit rate box and it was inches and centimeters, right? I know that 1 inch is 2.54 centimeters. Okay, so I can see, okay, well, what's happening here? I'm multiplying by 2.54, so that tells me that my equation is y equals 2.54x, right? Okay, that's like what our equation is going to look like, right? Okay, so we can look at that. Okay, you can see they give you, yeah, the equation is y equals 2.4x. Then for our x, which is our inch value, okay, I'm going to plug in 18. And then I just multiply them together and I get 45.72 centimeters. And it's just a similar, 45.72. It's just like what we've been doing, kind of. The same ratio, 2.54, 2.54. Okay. However many inches we have, we multiply it by 2.54, we get centimeters. Okay. Okay, so we have, let's try it here. It says a florist sells a dozen roses for $35.40. She sells individual roses for the same unit cost. Write an equation to represent the relationship between the number of roses, X, and the total cost of the roses, Y. How much would 18 roses cost? So they're essentially asking you to take this information right here, a dozen roses for $35.40, and they're asking you to basically find a unit rate, aren't they? Okay, so we're gonna find a unit rate. This pen is starting to go out a little bit. Let me get a new pen. All right, get rid of that one. Oh yeah, there we go. Okay, so we have roses and we have cost. Okay, and we know that 12 roses costs $35.40. and they want to know what each individual rose costs. And then at the end, they're asking us to find 18 roses. So we're going to solve this just the way we have been with our unit rates, right? We're just going to divide by 12. So if I take 3540 and I divide it by 12, it tells us that each rose is $2.95. So this is a couple things. This is our unit rate. It's also our constant of proportionality. It's also the K for our equation. So our equation is going to be y equals 295x. Because every value for the roses that I plug in, if I multiply that by $2.95, I'm going to get my amount of money, right? So if I take my one rose and I plug it in here and I multiply it by 2.95, my cost is $2.95. If I take 12 roses and I plug them in here and I multiply it by 2.95, I get $35.40. So I'm going to do the same thing with 18. Okay, I'm going to take $2.95 and I'm going to multiply it by 18 roses. I'm going to get $53.10. $53.10. Okay. Wrong one. Now, it's not crazy different, except that the fact that we're identifying what's happening here, we're putting our unit rate in kind of a second form here. Okay. We're already comfortable, hopefully, doing this. Now we're just taking basically this unit rate and saying, okay, this is what it looks like in an equation, right? Notice no addition, no subtraction. Only this straight y equals kx form, right? Okay, tells us that it is proportional, right? Okay. Let's look at the last one here. Let's look at our key concepts here. Okay. Oops. There it is. Okay, two proportional quantities, x and y, are related by a constant multiple, or the constant of proportionality. Okay, you can represent a proportional relationship using the equation y equals kx. Okay, how can you represent a proportional relationship with an equation? You can represent a proportional relationship using the equation y equals kx. Okay, so looking down here, how can you use an equation to find an unknown value in a proportional relationship? Well, when you have your equation y equals kx, you can plug one piece in that you know and get a piece that you may not. Okay. All right. And why does the equation y equals 3x plus 5 not represent a proportional relationship? Well, because we have this plus 5 here. So if I were to, so y equals 3x plus 5. So let's delve a little bit into why these equations that have addition and subtraction do not represent proportional relationships. Okay, so I'm going to put x, I'm going to put y equals 3x plus 5 is our equation. Okay, that's what's happening here. So let's have a look at it. So y equal, I'm going to use 3 examples. We'll just use 1, 2, 3. Okay, now remember, this is our unit rate, right? So when we plug something in with 1, we should get the same thing all the way across. So if I plug 1 into this equation, 3 times 1 is 3, plus 5 is 8. So when I plug 1 in here, okay, 3 times 1 plus 5. Remember PEMDAS, right? I have to multiply first and get 3, and then I add 5, so I get 8. So I get y equals 8. Excuse me. Excuse me. A couple sneezes there. So I get y equals 8. Okay. Now, when I plug, looking at my constant of proportionality here, right? What's happening here? Multiplying by 8, right? So in theory, this should be 16, right? 2 times 8. To keep it as a proportional relationship, that should be 16. This should be 24, okay? But when we plug things in that have addition and subtraction, that is not the case, okay? So when I plug in 2 to this, 3 times 2 plus 5, I get 3 times 2 is 6. 6 plus 5 is 11. I get y equals 11. So we can see that what is happening is not a proportional relationship. Because when I multiply this times 8, my constant of proportionality, or what should be my constant of proportionality, my unit rate, I can see that it's not proportional. Same thing with 3, when you plug in 3. Okay, 3 times 3 plus 5 is 9, plus 5 is 14. Okay, we can see these are non-proportional relationships. We can even see the amount we're adding is not the same. Plus 7, plus 9, plus 11. Okay, it's changing even if additions problems were proportional. Okay, they're not the same even when we look at this because it has both multiplication and addition. Okay, so that's the reason that falls under that non-proportional relationship banner. Okay, let's have a look here. Number 4. This is a great example here of what you might have seen on your warm-up the next day. Determine whether each equation represents a proportional relationship. If it does, identify the constant of proportionality. Okay, these are very quick. Look, -2, non-proportional. Okay, no, because it has subtraction. Okay, this one, no subtraction, so it is proportional. And what does a proportional relationship show a constant proportionality? Boom, just whatever number is nestled up next to x. So the constant of proportionality is 1,000 because that's what's multiplied times x. Anything I plug in as for x, I'm multiplying times 1,000 and getting y. So if I had 6 times 1,000, 6,000. Okay, and down here, oh, plus 1, nope, not proportional. Okay, pretty straightforward on those. Looking for plus or minus. If it has it, not proportional. If it doesn't, whatever number is tucked against x, that's the constant of proportionality. Okay. Number 5 says the manager of a concession stand estimates that she needs 3 hot dogs for every 5 people who attend a baseball game. If 1,200 people attend the baseball game, how many hot dogs should the manager order? Okay, 3 hot dogs for every 5 people. So that means if she multiplied the number of people, take the number of people, divided it by 5, and then multiplied it by 3 hot dogs, she'd get the number of dogs she needs. So in this instance, it's like, okay, we need it to be, it's 3/5 is your constant of proportionality times 1,200. Okay, so she took 3 times 1,200 divided by 5. She needs 720 hot dogs. Okay, I know I did that quick, but yeah. Okay, right here, a half dozen cupcakes cost $15. What constant of proportionality relates the number of cupcakes and the total? Okay, so again, this is just kind of building a unit rate box for this, right? Notice that the solution for, or the avenue to our solutions are all very similar as we work through this unit, right? Okay, we have cupcakes, dollars. So a half dozen cupcakes, 6 of them, costs $15. What is the constant of proportionality? We want to know what 1 cupcake costs. So if we divide by 6, we do that on both pieces, right? 15 divided by 6, so $2.50. So each of our cupcakes cost $2.50. So we notice we have a unit right here. It's also our constant of proportionality. So y equals 2.5x, right? Keep in mind, the unit rate and constant of proportionality are interchangeable. Okay, when they ask for a unit rate or they ask for the constant of proportionality, they're asking for the same thing. Okay, so those of you that have been solving for unit rates this whole time, solving for a constant of proportionality is not really any different. You're setting it up essentially the same way. Okay, don't get bogged down by the word jumble here. You're still kind of setting up unit rate boxes and things like that. Okay. You could do the same thing on this problem. I wanted to show you that before we talked about this one again. Okay, you have, let's see, let's just use the lines here. You have hot dogs and you have people. Okay, so they need 3 hot dogs for every 5 people. Okay, so if 1,200 people attended the game, how many hot dogs should the manager order? So let's figure out how many hot dogs one person eats. So 5 divided by 5 is 1. 3 divided by 5 is 0.6. So every person consumes 0.6 hot dogs. So if there's 1,200 people, how do we go from 1 to 1,200? Well, we multiply by 1,200, right? So I'm going to take 0.6 and multiply that by 1,200. I should get 720, and I do. Okay, so figuring out your unit rate, figuring out your constant of proportionality still helps us solve these problems. Okay, you can see we end up with 720 hot dogs for 1,200 people because I know what one person eats. This is my constant proportionality, so it'd be y equals 0.6x. For every person, x, they eat 0.6 hot dogs. Okay, this is one of those things, again, that like in the real world, like, okay, there's one person, how many hot dogs does he eat? 0.6. Well, okay, well, that doesn't make a lot of sense, but, you know, because who eats 60% of a hot dog, right? Plus, we all know this is a lie because we know that everyone eats at least one, right? Or more than one. How can you go to a sporting event without having a hot dog? Oof, man. All right. So, again, we are talking about kind of the same thing. Okay. I want to look a little bit at your Excel here just so you can see kind of the main ideas of what you're going to see here. Okay, how the questions are going to be asked. It's not going to be 10 questions. It's going to be probably 6 again. Okay. The equation below describes a proportional relationship between x and I. What is the constant of proportionality? Literally just whatever is nestled up next to x. So in this instance, 2/3. Okay, they're just identifying what the constant of proportionality is. This is another pretty straightforward. Okay, what is the constant of proportionality? Literally whatever is nestled up next to x. So in this instance, 3.71. Boom. Okay, not a real involved one here. Okay, an equation, P equals 6s. So this is still y equals kx. They're using different letters. Represents the perimeter of a regular hexagon with side lengths f. What is the perimeter of a regular hexagon with side length 3? So if they're telling us that the side length is s and that it's 3, we're just plugging that in here. So 6 times 3 gives us 18. Okay. All we're doing is, don't be confused by the difference of letters. It's still y equals kx. Okay. In a certain chemical, the ratio of zinc to copper is 4:11. A jar of the chemical contains this many grams of copper. How many grams of zinc does it contain? This is just the same thing we've been doing. This is a unit rate. Okay. We're going to build a unit rate and we're going to put in information that we have and then we're going to solve it. Okay. Copper, zinc. The ratio of zinc to copper is 4:11. A jar of chemical contains 286 grams of copper, so 286. Okay, so we're going to figure out a 1 value here. Okay, you can figure out a 1 on either piece. Okay, let's do it right there. Okay, because we know this value. So if we divide both pieces by 11, right? So I'm going to take 4 divided by 11, 0.36, 0.03636. Okay, and what's happening here? Oh, you're multiplying by 286. So if I take this value and I multiply it by 286, 104. Okay, same thing. Don't let the fact that it says it's constant of proportionalities and things like that, just change the fact that you're using a unit rate box, 104. Okay, we're still solving them in essentially the same way. Okay, the weight of 3 eggs is shown. Identify the constant of proportionality of total weight to total number of eggs. Okay, basically, okay, you have 3 eggs, and the 3 eggs weigh this much. You're just figuring out what your constant of proportionality is. How much does an egg weigh? So in this instance, you're just taking your weight, 132 grams, and you're dividing it by how many eggs there are, 3. Okay, 44 grams. Okay, and there's going to be 1 or 2 more. Again, this one's going to give you a stack of DVDs, and it's going to give you a total stack size. You're just taking this total stack size divided by the number of DVDs and figuring out what one DVD is. Okay. Okay, not that one. I'm going to write down which ones I'm getting rid of here. 7, 8, 9. I think the last one I'm going to leave. Yeah. Okay, same thing here. Selling stickers for number of sheets. Okay, you're just going to be dividing these down, finding your unit rate to figure out what your constant of proportionality is. So in this instance, you're just taking these. Oops. Come on now. There we go. So 675 divided by the number of sheets, 3. So essentially, all these should cost $2.25 per sheet. 31.50 divided by 14, $2.25. 42.75 divided by 19, $2.25. So that's our unit rate. So it's also our constant of proportionality. Oop, maybe not. Oh, 225x. Oops. All right. Okay. Okay. Keep in mind you got to put the equation in there. Okay. So yeah, 7 problems. Okay. So again, you'll notice, as I said, oops, let me end our video here. Okay.